Okay, let's start talking about fractals. So fractals are geometric figures, usually obtained through recursion, such that the parts of the figure look like scaled versions of the whole. More precisely, fractals can be defined as figures that are self-similar in that in that exhibit certain dimensional properties. Our main focus will be on the concept of self-similarity and the recursive procedures used to generate fractals. So we start by talking about basic definitions, okay? So one of the most important features of fractals is that they appear the same at different scales. This property is known as self-similarity. So self-similarity is defined as follows. A geometric figure is self-similar if it is exactly or approximately similar to one or more parts of itself. Intuitively, this means that the figure looks essentially the same from a distance as it does close up, okay? So self-similarity often appears in nature. In the Romanesco broccoli that's pictured below, if we zoom in on part of the image, the enlarged portion looks similar to the whole. So for example, if we look at, the whole thing, right? This whole thing, but if we, it has this general shape, but if we look at this part here and blow it up, look, it looks pretty much like the hole that is circled here. Okay. Now, also we can see that in the fern, right? So if we look at the fern, each leaf, right? And if we take this piece here and blow it up, it looks like a miniature version of the whole. Okay? So we see a lot of things like this in the natural world. This phenomenon also shows up in the physical sciences. For example, if we zoom in on the coastline of Portugal, each zoom reveals previously hidden details, and the coastline, while not identical to the view from further away, does exhibit similar characteristics. Okay? As we can see here. Okay, so as we take this coastal line, blow it up to this size, and we take this and we blow it up, it looks the same, or similar, I should say. Now, iterated fractals, okay, let's talk about them. This self-similar behavior can be replicated through recursion, repeating a process over and over. That is, we can construct fractals by starting with a simple figure and then repeatedly altering it according to a specified rule. To familiarize this process, we next introduce the concept of initiators and generators. Okay, so let's talk about that. So an initiator is a starting shape. A generator is an arranged collection of scaled copies of the initiator. Okay, to generate fractals from initiators and generators, we follow a very simple rule. Here is the rule. It's called the fractal generation rule. At each step, replace every copy of the initiator with a scaled copy of the generator, rotating as necessary. Okay, so let's take this example one here. It says use the initiator and generator below, however, only iterate on the branches. Sketch several steps of the iteration. Okay, so here's the initiator, right? Okay, and then here's the generator. What we're going to do is it's saying we're going to split this up. Okay, but we're only going to split the branches. So every time we split, we're going to split on the branches. Okay, so how would that look like? Okay, let's scroll down and we'll see. So notice that step one, we split this branch here, right? And then what happens? We split the two branches at about the same type. So right up here, right? So if I was going to circle, so we're splitting up here. Okay, so maybe it's a third of the way. Maybe we're doing 2/3 of the way or something like that. But then we get these branches, right? And then what we're going to do is in the next iteration, step 3, is we're going to split those branches the same way. Okay, and then we're going to split those branches the same way. Okay, and then so on. And if we keep going, we get a shape very much like this. If we keep going. Okay, which is kind of cool. Now, using iteration processes like those above, we can create a variety of beautiful images evocative of nature. Okay, for example, we look at something like this, or again, we look at the fern. That does something similar. Okay, so now, the triad. Okay, so I'm not going to, so in this case here, the initiator is the pentagon. So we have the pentagon, and what we're going to do is, the generator is saying, hey, we're going to put one on every side, right? Okay, we're connecting on each side. Okay, inside here. And so what you want to do is you want to find the next two stages in the process. Okay, so just like up here, we started with the initiator here. So number 1 was this, step 1. So in this case here, this would be step 1. Okay, and then in step 2, we're going to replace each one of these, because what we did was we replaced this, right? We replaced this with 5 of these. Okay, so now in the next step, we're going to replace each one of these 5 pentagons, with pentagons smaller that replace those. And then we're going to do that. So go ahead and do that. Okay, I'm not going to draw it because my artistic talent is not there. But go ahead and do this try-in. The answers are at the end of the chapter, so you can check your work. But go ahead and do the next 2 iterations of that and see what you get. Okay, just make sure you make it large enough, because they do get small very quickly. Okay, we'll leave it there. We'll come back. We'll start talking about the Coke snowflake.